guys, welcome to my video. So I guess everybody just interested in how to calculate the how to derive the continuity version of the Schrodinger equation. Okay, so the first section I will dealing with this Schrodinger, and the next I will deal in the Klein Gordan. So just some simple mathematical derivation. So I neglect 1 over 2m, right, because it's stupid. So I neglect. So this is the minus Laplacian psi plus v psi minus I partial psi partial t. So this is a Schrodinger equation, right? And then you can complex conjugate, so you get this term, this term. Remember that the minus I become I, okay? And then you times psi star to the first equation, and psi to the second equation. So you see the first two terms, I mean for this v psi star psi term is the same. So you can use this line to minus this line. So you get this. There are 4 terms. And then you change it into the gradient, sorry, it's the divergent of this minus psi star dot gradient psi plus psi dot gradient psi star, right? So you can change it into this, and the minus I this. Right, so these two terms is positive, right? So they are added together. So by the Leibniz rule, I can change this equation into partial t psi star psi plus divergent of this term. Okay. So by a continuity equation, partial t rho plus dot j equals 0, I can define rho to be psi star psi and the j to be minus I psi star partial psi minus psi gradient psi star. Okay, yeah. So this is the continuity equation derivation of the Schrodinger equation. Okay, so next equation is doing the same thing, right? So this is Klein Gordan. Klein Gordan basically is a wave equation, right? But plus a mass term, right? So this is a wave equation if there's no mass. Should be correct, right? This is a wave equation if you don't have this mass term, but you add a mass term, okay? And right. So idea is that we need to cancel this mass term. So let's first do the complex conjugate. Let's just first times complex conjugate to this original equation. You get this, and you times another complex conjugate. You complex conjugate and then you times psi, so you get similar 2 equations. And then you need to cancel this term, right? So you use first equation minus second, so you get phi star partial tt phi minus phi partial tt phi star plus these 2 terms, so it's minus phi star Laplacian phi plus phi Laplacian phi star. Okay. Right, so I can pull out 1t, right, become this. So if you use the Leibniz rule, there are 4 terms, right, but the cross term will cancel. So partial t phi star partial t phi minus phi partial t phi star plus divergent of minus phi star gradient phi plus phi gradient phi star, right? So also the cross term will cancel, right? So you can change this into partial t rho plus divergent j equals 0. So from this rho is here and the j is here, right? So j is a vector, so that's why. So if this is a gradient, right? So remember, if you use gradient of the scalar, then it give you vector, right? So j is a vector, rho is a scalar. Okay, so yeah, so this is a continual equation of the Klein Gordan. Okay, so I will see you guys in the next videos.